Okay, and welcome back to another video coming live from my study. As you can see by the hair, the isolation is starting to take its hold on me. I think I'm in pretty serious need of a haircut, but I don't think I can go as far as to shave it off, so we'll just have to put up with it for now. Alright, so today's video we're going to talk about line graphs. So we're doing maths, and in maths this next few weeks we're doing stuff on data. So in data we have lots of different types of graphs. We had column graphs, bar graphs, line graphs, pie graphs, all sorts of different things. Picture graphs, things of this nature. Today's one we're going to talk about is line graphs. Now line graphs are usually used to show change over time. So that change could show the differences between what happens each second, each minute, days, months, a year. Give an example, a few examples. If we're showing how the temperature changes throughout the year, through January, February, March, April, goes all the way through, a line graph would be a really great way to show that. We might show how our heart rate changes throughout each of the minutes. So if we're doing exercise on a treadmill, and we might show in the first minute it started here and then it kept going, spiking up and down, and it really clearly, that line graph, if you're unfamiliar with what I mean by a line graph, I mean this sort of graph, would be a really good way of showing how that is changing over time, and then you can really pinpoint any differences in what's actually changing and what's happening in this, because I think it's a really easy visual. Unlike bar graphs and column graphs, which usually put in categories. So we'd have things that we know, like we'd have like what's people's favorite fruits, and we've got apples and oranges. This is usually tracking one thing over a period of time. So you could chat like the temperature of the world with global warming and with climate change, and how the temperatures of the world are over throughout history, and they've slightly started to go up. A line graph would be a perfect way of doing that, rather than a column graph, which really there would be no way of doing that. So like I said before, this is an example of a line graph. Once again, they've got a title, perfect. They've got their x-axis labeled down the bottom and their y-axis labeled over here. And this one's about the amount of push-ups that a person did. And they've got their blue line here saying they did 25 of them from the first day, then 15, 25, 5, 10, 0, and 20. So that really enables you to actually get a lot of data from that and actually start asking questions like, why did they do 0 on Friday? Did they have a break? What happened here on Wednesday? Why didn't they do many? And it's a really clear way of seeing this, whereas column graphs, this might not look as easily, it might not be as easy to understand that. So it's a good way of tracking it throughout the time of the week like that. Another example here. Now this is an example of what I think is harder to show in a column graph, which is to show multiple things at once. So here we've got bears, dolphins, and whales, and we're tracking what the population of those three animals has done over the past few years, or what their projection, is what's going to happen to them from 2017, and what they were projecting was happen by 2022. So you can really see here, it's a really clear visual that bears are on the up. They're assuming that bears are on the up. Whales are a bit up and down, and that dolphins seem like it's a real dying population. Now, I don't really know how accurate this graph is, so don't take this as fact. I'm just saying it's a really clear thing that there's multiple things going on at once, but it's really clear once you know what the key is down the bottom, what's actually happening. But if you look at that, what we did yesterday about the side-by-side graph, I find the side-by-side graph a little bit confusing. So this is like, say if they're doing the difference between men and a chart on graph between men and women on something about marriage. Having to track both of them at once, looking at I find that a little bit more confusing. And I think it would be easier if they had one blue line going as a line graph and then another line as a red graph, and it would be easier to see rather than these columns getting in the way. So if you've got to track those things over time, rather than doing it through a column graph, I would track it through a line graph. Okay. Here's an example of the average temperature in Edensor Park for last year. Okay. Now there's a lot going on here, and I think sometimes people get really confused, and it's good to just see what each of them mean before we get confused, because some of them we can wipe out and not even worry about. We're looking at the temperature each year, and why would we be looking at this? Well, we were looking at last year was a crazy hot year, so we kind of want to be looking at how hot was it, right? So we're going to try to rule some things out. So we've got here, there's a lot of things. So the blue one says the lowest monthly mean. Now we're going to go through that again soon. Mean means average, okay? So the lowest average temperature over all the years. I don't want to know the lowest, I want to know the average, okay? Then we have the highest monthly mean over all years. We don't really care about the highest or the lowest. We want to just know the average for those times. So we're left with the mean temperature, the average temperature for all the years of recorded temperatures in Adenza Park, and the mean average for 2019 in grey. So we're looking at the grey and the green one. The grey one is just last year, and the green one is every year, and the averages, okay? So let's track them. Already, we can see in January, the grey one was way hotter, okay? A couple of degrees hotter average, okay, than it usually was over the history of how long they've been recording them for. Then we can see that these slightly above average, kind of okay in June. July was a bit hotter. August was about average. September was average. October was getting really hot. By November, we're talking some serious differences between the average temperature of a normal November and December and what it was last year. We're talking now the red one, which is the highest average they've ever really had. So we're talking the highest year on record, quite a few degrees each day higher than what they've ever had before. So by just looking at the green and the grey ones, this actually makes a significant difference. What I'm going to say is interesting because you would assume with the temperature that only goes up to 35, that you probably would start from 0, but they haven't chosen to start from 0. They've chosen to start from 15. I think what they're trying to say is if they started from 0 and only went to 35, the differences between summer at 32 and winter at 16 might only look really minuscule. But to us, that temperature feels very different. So by really expanding that part and only focusing on like that 20, there's only 20 degrees there, that's because 20 degrees feels hugely different. The difference between 0 degrees and 20 degrees is massive. So they've actually only started from 15 rather than 0 because 1 or 2 degrees in temperature actually does feel like a lot. Okay, so that's why they haven't started from 0. That's why you'll never hear me say don't ever start from 0, or you won't hear me say always start. You won't hear me say those things. It's a case by case basis based on the information you have. What you will see though is this symbol. I know a couple of you have seen it and we're a bit confused by it. That symbol there means we haven't started at 0. We're going to make that little line there which shows that we know that 0 is there, and we're going to show that one, and then we're going to start from our number, which is 5.6. Okay, so that's their version of saying we're not starting from 0. That's like we're going to squash that part in between and squash it into nothing, and we're just going to start from this number. Okay, that's what that means. Like I said here, if we're talking about the world population, how much it's going up, if they started from 0 over this time, and then that's only gone up from 6.1 to 7.2 billion, that's huge. And if they shrunk it down from 0 to 7, it might only look at that much, but that's 1 billion people. So you've got to look at what you're actually doing. Now, what you're going to do today is going to be also your PE homework, which is quite interesting. What you're going to do is you're going to find someone else. I said someone else, but let's get rid of that because you don't need anyone else to do this activity. You probably will need someone else to time you. I will say that because otherwise you might cheat. Okay, and you're going to draw a table, and you're going to have star jumps as an option and push-ups as an option. Okay, and you're going to have first attempt, second attempt, third attempt, and fourth attempt. Okay, then what you're going to do is you're going to stand there, and then someone's going to say go, and you've got 30 seconds to do as many star jumps, proper star jumps as possible. At the 30 seconds, once you've counted, you write down that answer. Then you go across and you do push-ups. They say ready, set, go, and you see as many push-ups as you can do in 30 seconds on the ground. Do once properly, please. And then you write that number down. Give yourself a bit of a break, come back again, do the second attempt. It's star jumps, then a second attempt at push-ups, and then keep going. What you'll see by the end of it is we'll be able to see which one you could do better, star jumps or push-ups, but we're also going to see, did your body get better at doing star jumps and push-ups as you went, or did your body fatigue and get tired and then slowly they started to drift off? It's going to be interesting to see the results, and we're going to see clearly what the results were, because I find that personally, I might be able to challenge myself harder after the first one, but I also think by the fourth one, we might see it start low and then get back up, and then by the fourth one, when you're really tired, you can have a go. That's why you can have a break if you want. There's no real need. However, what we talked about like accurate results, we can't really ever track each other. I can't track you against me if you don't have a break and I have a break of 2 hours every time, because then it's not fair. So then you've said you've done 20 star jumps and I've done 30 star jumps or whatever, but you've had a break and I didn't have a break. So if we're going to compare them against each other, we would need to make sure we had the same conditions, but you're going to do it against yourself, in which case you would give yourself the same distance. If you're doing the first attempt, then 10 minutes, then the next attempt, then 10 minutes, then the next one, then 10-minute break. Don't have like a 3-hour gap and then come back completely refreshed and smash out the last one. That's not what I want. Okay. Then you're going to try to turn your results, once you've tracked them all, into a line, might be like a blue line here that goes as your push-up line, and then your star jump line, and that would be a separate line. And you go first attempt, second attempt, third attempt, fourth attempt, and plot them along, and then do your line graph. Okay. You would need to then label your y-axis, which would be number of times. Yeah. And this one would be down here, activities, or I don't know what you'd call it. Exercises, let's call that. And then exercise activities might be your title, and then you've got all those things labeled and you can plot them on. Now, I haven't actually given you this worksheet. I would hopefully you would have your maths book at home. If you don't, I will give a grid that you could print out. Otherwise, I think you're just gonna have to draw it in one of your other books and rule it up as properly as you possibly can. Okay, so remember, line graphs are when we're tracking something over time. We're not tracking different categories, we're tracking 1 or 2 or 3 different things and how they change over time. I really look forward to seeing how you're doing, and I will try to do it as well, and we'll see if we can compare the results tomorrow. All right, thanks very much for watching.